Imagine, if you will, it's an ordinary day at the office. Things are progressing swimmingly. And out of nowhere, you're hit with a cyber attack. More specifically, a SQL injection. Let's take a look at the Splunk team at TanukiTech and see how they're handling the situation.
So Splunk provides a capability for executives to have a view into their business. And you can see we have a glass table here, which is basically monitoring the TanukiTech's health of their web applications. And if you can see from the glass table that we're having an issue where we don't have any checkouts, which is concerning. And if you look, we have KPIs associated with each tier here, and these are dependent on each other. And if I follow that through, you'll see that we're having an issue with our database. And so Splunk's able to take all the system logs, data logs, pull that in, and then we're able to do analysis on that. And we're also able to not only native logs, but we can pull in logs from, let's say, application, app dynamics, sorry. So we could take that data and correlate that data with the system logs that we pull in from Splunk. And so let's dive into our operational visibility. So we know we have an issue potentially with the database. And if you take a look in our operations visibility dashboard, you'll see that our latency time for database actions, transactions has gone up in the last few minutes, right? Last 30 minutes or so. So something has happened where we're having a problem with database transactions taking a long period of time. So if I drill down into that data, you'll see we could take a look at what particular transactions are taking longer. I could take a look at the top query run times and see what particular queries are being done. And if I take a look at some of these, I'll see that there's actually something strange going on here. We have a select password, which is kind of an odd thing. We have a select star from HR, and we could drill into the actual raw data and see, what's happening with that data, where that's coming from. So we can also, from that point, take a look at, so we have an issue where database transactions have gone up. So what possibly has changed, right? So I could go into my application delivery glass dashboard and take a look at, what's happening from an application delivery perspective, or what changes have been made, so if I take a look at applications by version, I could see the errors per version, right? And so if I take a look at this, we'll see that 4.6 seems to be generating a lot of errors for us. And if I take a look at our last commits, we'll see that we have a commit was made 43 minutes ago. We pulled in this data from GitLab, right? So we could see, the changes that are happening in GitLab, compare that to the data in our performance. And we could see that we had a change that was made by Billy the intern, just made his first production commit 43 minutes ago. And that sort of ties into, when our issues started to arise. So we have a case where we have operational performance problems. We take a look at that and we see what queries are happening, and those queries are suspect. They actually look like maybe some sort of threat, and we're able to determine through our application DevOps dashboard that coincides with the change that was recently made by Billy the intern.
Very interesting. Turns out the smoking gun is Billy the intern. He was doing what any good intern does by executing a version release. But wouldn't you know it, he fat-fingered the code and left it wide open. That left the application vulnerable for infiltrators to have their way with it. Based on what it is that we've uncovered, I imagine they have to be seeing some pretty interesting things in the AOC. Let's see what App Dynamics has to say about it.
When we take a look at what App Dynamics provides, we'll find that App Dynamics is going to automatically discover the topology of this TanukiTech application. We see that there's correlations across all of the layer 7 components, and there's a discovery into backend calls such as HTTP-based web services, as well as databases. And it's possible that we would discover that erroneous line of code and this SQL injection vulnerability by looking inside of the snapshot data that AppDynamics provides. By default, AppDynamics is going to look at every single transaction and start to baseline all of the metrics automatically and then discover anomalies. So we can see in this case, AppDynamics is counting every single request, measuring the response time, and also discovering any errors that occur. And AppDynamics is actually learning, using machine learning and AI ops, what the normal trend of behavior is for this application, as well as any anomalies that may occur. And AppDynamics is going to be able to take action upon anytime there's an anomalous transaction, such as a slow or a very slow. So let's take a look at some of the anomalies that are going on right now within this TanukiTech application that may correlate to this strange behavior that we're seeing from the end user's perspective. So here we can see all of the slow transactions and the very slow transactions that have occurred in the past 1 hour. And in this case, they're sorted by the slowest. And in this case, we actually see there's one that took over 100 seconds. Definitely anomaly in terms of this specific type of functionality, which is the website login. So we want to take a deeper dive and actually understand what was going on when this specific very slow transaction occurred. What we're looking at here is an automatically generated flow map for this transaction. So AppDynamics has traced the entire request response lifecycle from the browser all the way through the data center across all the different servers where this transaction, this specific website login has occurred, as well as calls into dependent resources such as queues and web services. And here we can actually see that the slowest part of this journey was this 1.7 minute hop from employee services back to the Oracle database. Using machine learning, AppDynamics is actually able to pinpoint where we should start looking. And we can see that many of the slow transactions are actually SQL queries. So AppDynamics is automatically giving us insight into where we should start looking for problems. Also, we can see that this specific snapshot is able to be referenced via URL. So AppDynamics could send this message as an action to an external system to open up troubleshooting to other teams across the enterprise. So in this case, what we'll do, since we've identified which transaction in the application is actually very slow and has hit that anomalous threshold, we can start to drill down and actually see what's going on. So with AppDynamics, we can go right into the JVM and start to look at the call graph, which is the line of code level visibility inside the transaction. We can actually follow this specific transaction by line of code inside the JVM, and we can see what this thread is executing. In this case, we see that the very slow line of code is execute Oracle query, which is tied to a JDBC exit call. And it's taken over 98% of the time. So this is something we definitely want to investigate. As we see what's inside that JDBC call, we can actually uncover the SQL, and we can see that very same piece of evidence that was surfaced earlier where the user ID equals 105. And so this is a very strange finding, which we could attribute to a security vulnerability that's been violated by a malicious threat. And so one of the things that we could do is issue or create an issue inside of GitLab using that URL that was shown earlier and allow for the development teams and other parts of the enterprise to investigate further. And that's what we'll do now.
Hold the phone. You're telling me that the algorithms of the machine learning agents drilled down into the root cause of the issue in 3 clicks? And in doing so, they found the specific line of code resulting in user ID 105? Now that we know that the problem is, what are we going to do to fix it? let's see what GitLab has in mind.
All right, so now we know, there's an issue here. It looks like there might be some SQL injection done to the database that maybe has caused some damage to our application. We've opened up an issue on the GitLab side. So now from the GitLab side, we're going to step through the process of actually dealing with this and remediating the problem that we found. And I can see now coming in on a Monday morning that there's a new issue on my board here that's related to this problem, and it's something related with the 4.6 rollout. I'm going to go ahead and open up the issue. And within here, I can see this, that there's definitely an issue with the application. I see that there's this 105 issue or text that was injected into the database, the user ID that we spoke of before. So let's go ahead and verify the problem with the actual application from within GitLab and see what we can detect. So we're going to pop into our environments real fast. This is a Kubernetes application that it's running on. And I can actually dive into the Kubernetes instances to see if there's actual error messages related to this problem. For this type of problem, there probably wouldn't be any actual error messages. So we're going to pop into the actual application now to see if there's anything we can detect or at least confirm from here. And from here, I can see that something definitely has impacted the password field for this application. Again, maybe the SQL injection changed some parameters within the files of the application, but our passwords are no longer masked. So that's a big security issue. Now that we've confirmed this, let's go ahead and deal with this and remediate the problem. Going back into the issue boards, the first thing I'm going to do is just basically take ownership of this issue, throw it into my doing section, and start getting to work on this. As this is a Sev1 issue, I know that I got to work on it right away. So going from the issue itself, I've already created a merge request for this. So we're going to go ahead and dive into that merge request right now. All right, so this is the actual merge request. So basically what happened is we put the issue into a work in progress state. We're always staying linked to that original issue so that once we do merge this, it's going to close out that actual issue. We're working on a separate branch now. We're not working on master so that we're not impacting any of the users at this time, just to make sure that we've got everything correct. So what we'll go ahead and do is we'll open up our web IDE that's built into GitLab, and we're going to go ahead and check that file that we think has an issue related to this injection problem. And if I scroll down to the password field, immediately I see something there is wrong. So I'm going to go ahead and fix that real fast because this is a password field. It's not a text field. So we're going to go ahead and commit the change. And you'll see that we open up a split screen at this point just to kind of compare the before and after to make sure that everything that we've done in there is correct. And it looks good, right? So all we're doing is we're changing this over to password. So we'll go ahead and stage that change and commit the change. All right, and commit. And what you're going to see happen now in the back end, or I should say in the bottom left-hand corner, we're going to go ahead and kick off a new pipeline. And this is a pipeline that's going to put the new code through a series of tests. Now, this is a very simplified pipeline that we're working with right here. But to show you a fully baked one as we go through that, what we're going to be doing is basically building out the code, learning what kind of language it's written in, checking the code quality, doing a vulnerability scan of the container, doing a dependency scan, license management scan, so based on whitelists and blacklists of licenses. And then we get into our security testing, right? So we want to make sure that the application that we're passing through does actually, work with all the security tests. So we're going to do static testing first. We stand up a review application, and then we do our dynamic testing against that review application. And then we can pass over to performance testing as well. So let's go back to the original pipeline. And it looks like we're done. So what we've done is we basically gone through all the testing and we stood up the new code in our review application. So let's go back out to environments real fast. And this is our review application. So initially speaking, we only had our productions and our staging, but we built this out when I created that merge request. And basically it is its own little sandbox for us to do the testing. So I'll open up the live instance of that, and you can see my change does look like it took effect here. So it looks like it's fixed. It's secured, and we're ready to go ahead and merge that back into production and start monitoring it from that point. So what I'm going to go ahead and do is go back into the merge request now. Everything looks good. There's no valid approvers. If approvers were required at this point, maybe security testers or security group, code reviewers or what have you, they could come in here and check that the code before actually passing it through by looking at any of the changes that have been done in the code. So this is where a code reviewer would come in and actually check it before approving it. But for right now, I don't need approval for this project, so I'm going to go ahead and resolve the WIP status. We'll delete the source branch to keep things clean, and we'll go ahead and merge it. And what's going to happen is we're building out a final pipeline right now. So this pipeline is a little bit different in the sense that we're going out to production. So we actually have two pipelines. One is just cleaning up that old environment, that old Kubernetes environment, and recovering the resources for the next one. And then we're also, at the same time, we're pushing through a new pipeline. And this pipeline is a little bit different than the last one because we're going to go ahead and push it out to our staging environment at this point. It's going to stop here before I actually roll out to production. And once it gets to that point, I'm going to be able to push out to maybe 50% of the users or all of the users in production. So that way I'm causing minimal impact if there's any concern about rolling this application out. And you can see that this pipeline is almost complete. One thing that you can do while watching the pipelines, if there's any issues, you can actually go into the pipeline itself and watch the raw output as it's being built. Let's see if we can see it right here. There we go. So if there is any issues with the pipeline, you can actually do some troubleshooting from this pipeline, from this raw output. Looks like it succeeded. So it looks like we have it out into the staging application or staging app, and we're ready to push it out to production. But before we do, let's just do one final check to make sure. It looks like my fourth environment has been cleared out. It looks like my merge right here, the last commit was the merge that I just did. It's still got the old code there, which I haven't pushed yet. We'll do a quick test. Looks like that worked. So we know that the right code is in the staging environment. And what we'll do from here is we'll go ahead and finish out rolling out this fix to production by simply going back into this pipeline. And I'm going to go ahead and roll it out to everybody since this is an urgent issue. I'm going to go ahead and roll this out to everybody. And at this point, within a few minutes, we'll have the fresh code out to the production servers and ready to go.
Jim Mitty Christmas, you're telling me that Billy the intern coded the release with the password field in clear text? That's like leaving the front door open to the crown jewels. Luckily, they have a single application to manage the full software development lifecycle, remediating the issues, securing the code, and releasing it back into production from one interface. Now that it's fixed, what does the current state look like? Sami, what do you got for me?
So now that the fix has been implemented into the new release of the TanukiTech application, we can return back to AppDynamics and actually see the impact of this change. Here we have a dashboard that compares version 1 versus version 2. So version 1 was the release of the TanukiTech application that had the vulnerability of the SQL injection attack in there. And we can see that the login rate and the percentages, as well as the total number of logins, are a lot lower than if we go look at what was the same set of metrics on the release after the fix has been implemented. So we can see that as an aggregate, the application is performing significantly better just for the login transaction. And we're able to compare that just by looking at the real user traffic within AppDynamics. We can also see how that login fix has affected other workflows within the TanukiTech application. In this case, let's look at an important workflow where website login is used to access a profile and convert an offer that's provided on the website. We can see that in version 1, there was a lot more yellows and oranges and reds, meaning errors, slows, and very slow transactions that occurred after the login. And that indicates definitely there's some issue going on with version 1. When we go over to version 2, we see a lot of those issues have been resolved and the conversion rate is significantly higher. And overall, the application is much healthier. So we're able to prove that the change that was implemented in the previous step has taken effect and gotten us to the desired outcome of improving the overall performance of the application.
That was a close one. It's great to see industry leaders working together on a united front, protecting our citizens' health, wealth, and liberty. In my line of business, this is when we say, case closed.